I'm Chris Ellis. I'm a chemistry professor here at KU, and I'm a physical chemist, so I've studied ultrafast spectroscopy. I did my PhD at the University of Wisconsin, and I did a postdoctoral research at Southern California and Argonne National Lab. Throughout that time, we've been interested in trying to understand really fundamental details about what makes chemical reactions happen, and that's the research that we're continuing to do today in my lab here at KU. So the research we're interested in here is really about understanding what makes chemical reactions happen. So we use a technique that's called ultrafast spectroscopy. And ultrafast spectroscopy studies the dynamics of chemical reactions, so really on the time scale that the atoms are rearranging themselves. We're interested in trying to understand what makes what's responsible for bonds being broken and being reformed in chemistry. So it really comes down to the fundamental details of chemistry. But students are really responsible for getting things up and running. They get to work on the laser table, work on the optics. They get to set up the experiments and decide what we want to pursue in terms of the chemistry, and then work on the analysis to try to understand what the measurements are telling us. So I've had students go all different directions. I always tell my students that what they're gaining here is good technical experience, and it sets them up for all different kinds of opportunities down the road. I've had some students that have gone into teaching, I've had some students go into industry, and I've had quite a few students go work at national labs. And in the national labs, they've been able to carry on research with laser spectroscopy and turn that into great careers. Well, so we have a nice laser setup down in the basement. So we're fortunate to have a really great set of labs where we run our measurements. Beyond that, we use some of the other facilities. We've used the instrument shop to make some of our kind of unique instrumentation, and we've used the electronics lab to set up all of our detection. So we tend to collaborate a lot. We've had collaborations within the department, working with Marco Caricato in theory. We've also worked with people outside of the department. We've had a lot of synthetic groups who make really interesting molecules for us to study. And we've had opportunities to go make measurements at national lab facilities using either the synchrotron at Argonne National Lab or the free electron laser at Stanford. And so students have been really deeply involved in those projects. And those are kind of fun projects because we get to go out for a week, spend a week at the national lab, and 24 hours a day of measurements. You get to know each other pretty well and get to have a lot of fun with the science.